A particle starts at origin at t is equal to 0 seconds with a velocity of minus 5 I cap and moves along the xy plane with this particular constant acceleration. Okay. First thing is, let's analyze all of it. So the particle to begin with is at 0 unit away. And then we have velocity to be minus 5 meter per second. And it moves with an acceleration of, so we have an acceleration of 3 I cap minus 4 j cap meter per second square. So it's accelerating both in x and y axis. So here the object has a velocity of only along the x axis, right? It's going left basically. This, for your understanding, it's going left. With this acceleration, within 2 seconds, it will start coming towards the origin or the y axis. I don't know if you guys understood what I just told. But yeah, if you pause and think over, you will understand what I just meant. Okay. At what time is the y coordinate of the particle minus 20 meter? Y coordinate, okay, it will go to 20 within 5 seconds. How did I find that? Just take this. Oh, it's accelerating also. So not 5 seconds, it will be before that. So it will go 4 and then it will cover 8. Some fractions. What is the x coordinate of the particle at that time? Again, a good question. So for this, I'll figure out my r, which is r naught plus u ut plus half a t square. So this I represent with v naught though. So this is a 0 that I can ignore. This is minus 5 I cap t plus t square by 2. I'll just continue with this. 3 I cap minus 4 j cap. Now I'll combine all the i's together. So minus 5 t plus 3 by 2 t square I cap and then the j's together. Minus, or let me write plus of, minus 4 t square j cap. Okay, so we need to figure out at what point of time the particle is at minus 20 meter along the y-axis. Basically this. For y is equal to minus 8, minus 20, sorry, meters, we have minus 4 t square is equal to minus 20. Is this correct? Is it not? This has to be the case. Y component, that's it. See, it's that simple. Simplify this. How much will this be? 5 and root of 5. So many seconds. Done. What else next? What is the speed of the particle at that time? Oh, what is the x coordinate? So therefore, let me change the color. Therefore, x coordinate will be, yeah. So x is equal to minus 5 root of 5 plus 15 by 2. So many meters. Again, if you guys want to simplify, please do that. I'm not going to do that. Then what else? What is the speed of the particle at that time? So P of t is, I can figure out with, oh yeah, I didn't do this for previous question. I should have done this. I can just take a differentiation. So this would be minus 5 plus 3t I cap minus 8t j cap. Okay, and then we have the speed at that time. So we have to figure out the velocity at root 5 minus 5 plus 3 root 5 I cap minus 8 root 5 j cap. And the speed will be root 5 will be, okay, this you guys have to simplify, plus 8 root of 5 the whole square, ignoring the negative sign, the root of this. All this is the math only, guys. This is only to, this is supposed to be done with calculators. The questions are supposed to be with calculators. Okay. So please ignore the calculation, as in you can just stop it. It doesn't matter. No point in getting answers with calculator. So if you're able to understand what is happening over here, and how do you get answers from different places, right? Here I could have gone with another way. Actually, I used to do that. Now I just realized I could have just taken derivative. It's much faster. And I just did that. So you can see that as and when you do more questions, you will get hang of it. Things will become easy. Try to differentiate, as in try to see I as along the x-axis, y as, and j cap as along the y-axis, and keep them apart, segregate them, and when we have to combine them, understand when to combine, and understand that all of this question is pointing towards one fact, that all of this complex motion, it can be 2-dimension, 3-dimension, a drone, a rocket, whatever it might be, you can end up with understanding them with just this, using unit vectors. Everything can be understood in that way. That is motion, regarding to motion.